The word nucleophile is a very important term in organic chemistry. The word literally means nucleus lover. So, what is a nucleophile? If we look at it in general terms, a nucleophile will always have at least one lone pair of electrons, will almost always have either a partial negative or a full negative charge. It could be an ion, could be just something that's delta minus. And the important thing is that that pair of electrons, that non-bonding pair of electrons, can become a bond. So the lone pair can become a bond. This comes from the Lewis dot structures idea. If we had X and we said it has two dots, well, if you put that next to, for example, a carbon, that's a bond between X and C. You must imagine this nucleophile to be mobile. Organic chemists like to say the nucleophile will attack another molecule, which means it's mobile. It may have other things attached to this X that affect its reactivity, absolutely. But in simplest terms, all we need is this. Let's have this nucleophile attack a carbon. So here's a molecule, carbon-based, because organic chemistry is all about carbon-based molecules. Let's make it be tetrahedral. Let's have it be polar, so that we have the molecule with, let's put a Cl here. So Cl is electronegative enough to pull electrons away from the carbon. So you have this sort of structure here. This carbon would be called electrophilic because it's delta plus, it's attracting things that have electrons. So now here's where the attack occurs. This nucleophile could move towards the positively polarized carbon. This pair of electrons here can form a bond with the electrophilic carbon, and that will make a new molecule. So here we go. Let's imagine now what the products could be. Carbon will still be attached to these three unspecified things here, but now it has a new bond to the nucleophile, to the X, to the nucleophile. So it's made a new bond here. The carbon can't have 5 bonds stably, and so this chlorine here has to go. It's called a leaving group because it's going to leave. In this case, the chlorine will leave with a negative charge. So this is a typical reaction in organic chemistry where you substitute this chlorine for a new species, which I haven't specified, but it is a nucleophile. The nucleophile has displaced the leaving group chlorine. You're going to be making esters. What are the important nucleophiles to be aware of? The first would be an alcohol. Alcohols are a general family, where this could be some carbon-containing species, simple as CH3, maybe 2 carbons, 3 carbons, 17 carbons. Attached to an OH group, this is not hydroxide, but it is sometimes called hydroxyl or hydroxyl. It's not an ion. You can see delta minus, you can see the lone pairs here. 1 pair of electrons, 2 pairs of electrons. That makes it a nucleophile. And that will be something you're trying to react with with a carbon species that is electrophilic, and that will be carboxylic acid. So here's a delta plus carbon, here's a delta minus oxygen that is primed and ready to have a reaction. So here, one of these lone pairs, doesn't matter which, can attack this carbon here to form a new bond. That's how you'll make an ester. Another important nucleophile that you should be aware of is this one, HOH, better known as water. This is again delta minus. This is again lone pairs of electrons. It's a nucleophile. So water is a common nucleophile and one that can destroy the ester that you make. So you'll be thinking water is your enemy in this project. It will reverse the reaction you're trying to make happen. Hydroxide is also a nucleophile. It's maybe 1,000 times more nucleophilic than water. So this is a very dangerous species to have near your ester. So if you have a base in there, look out. Your ester may die very quickly. Another species that's an excellent nucleophile, I don't see why you would ever have this in your reaction mixture, but ammonia, or its close relatives, the amines, this is an excellent nucleophile and will react very quickly compared to things like water or an alcohol. So depending on what your desired product is, this may be a good choice. In your ester project, it's not going to be a good choice because it doesn't make the molecule you want. But keep in mind, ammonia, amines, excellent nucleophiles. You may have use for them later on in this project.